Okay, so this week we're going to talk more about the COVID, and we're going to focus on the flattening the curve this time. We'll talk about what they mean when they say that in the news and a little bit about the structure of a virus and how it works. So first thing, obviously, just watch this video to get an outline of what's going on. Number two, you're going to find a graph or a table or infographic. You could use the infographic you have from last time. And use it again, because the third thing you're going to do is write a one paragraph analysis. So last time you wrote a results, which was just explaining the data in terms of the trend, like is it going up, is it going down, what's happening with the data. The next thing you're going to do is write an analysis, which is for this one paragraph that's going to explain why your data happened. Okay, so you might have chosen a graph from last time. Last time I told you not to try to explain why, to just describe the trends. Today, you're going to try to explain why. Okay, so think of maybe one news article or one thing you can add as your citation. So you can add one citation to this, and you're just going to write a paragraph explaining why it happens. So to help you understand why this data is happening, let's talk a little bit about viruses. Okay, so this was the image they have created. That's an artist rendering of the data that they have of what the outside of the virus is thought to look like. Okay. So as far as we know, new illness affects your lungs and airways caused by the coronavirus, obviously. Okay, so the range of your symptoms can be mild, cold-like cough, high temperature, shortness of breath, to requiring a respirator, sometimes death. So obviously this is very different for each person. So they keep saying if you are immunocompromised, or if you're older, or if you have issues with your lungs or shortness of breath or asthma and all that stuff, you'll have a harder time with this. But those are the basic symptoms. Okay. Also, so let's talk about what is a virus then. So this is the picture of it on the right. So you can see that on the inside, there's going to be some type of genetic material. In this case, the genetic material is RNA. So it's slightly different than DNA. Just the backbone is a different sugar, but it's just genetic material in the middle. And then on the outside, you're going to have different proteins, okay? So viruses are not considered to be living because they cannot reproduce on their own. So they basically use your cell to make more copies of themselves, okay? So if you look at this next picture here, this is the way that they're able to use your cell to make more copies of themselves. So whenever you get the flu or any sort of virus, this is basically how it's working. So you can see on the outside here, this is your cell membrane with the yellow right here. And what happens is that the virus is first going to sort of attach to your cell membrane, okay? And then the genetic material is going to somehow get into your cell. There's many different mechanisms depending on the type of virus. But for our case, let's just say, okay, great, the genetic material is in here. So we saw before that it was something called RNA. RNA basically gives your ribosomes instructions on how to make proteins. So it says right here, this is virus RNA, and it's giving it instructions on how to make more virus. Okay, so basically it keeps making more virus, more virus, more virus, and it gives instructions on how to make more copies of this and how to make more copies of the stuff on the outside. Okay, so you can see that after these steps of making more copies of the virus components, okay, they get assembled and then they get pushed out of the cell as well. So basically this is how a virus is able to sort of use your own cell machinery to make more copies of itself. Okay, so again, just to reiterate, the virus enters the cell, it's going to release its RNA, so the genetic information. The ribosomes that are in your body are going to use the information on the RNA to make the proteins, so all of this stuff on the outside of the virus. Remember, all living things have the same sort of genetic material, so your body can understand what this RNA is, okay, because we all use the same type of coding, and so the cell makes more and more copies of the virus. So how it spreads, from what we know, it's airborne particles is the most common way, so it travels up to 2 meters, but what also complicates things is it can transfer from a surface where particles have landed. So when you touch the surface, then you touch your eyes or your nose or your mouth, so that's why they keep saying don't touch your face, okay, because they last a different amount of time on different surfaces. So We don't think so far that we think that fabric is not a big deal. It's about 3 hours. Wood and copper, again, really short for how long the virus remains, I guess, say active. On cardboard, 24 hours, metal, 42, plastic, 72. So somewhere around there for these different surfaces. So that's why they say if you're getting something from the grocery store, if it's cardboard, you might want to wipe it down because it's going to last 24 hours on the outside. So if whoever's stocking the shelves, you buy something that's cardboard, you bring it home, you might want to disinfect the outside, or just take out whatever's inside right away and then toss the cardboard so you don't have to have that in your house. Okay, so next is the methods that your body has to sort of fight off the virus. So first you want to look at the innate ways you have to prevent it from hurting you. So this would be your skin. Okay, obviously the virus can't get into you because of your skin. You have mucus, you can cough, sneezing, stomach acid. All of those things are ways that you can stop the virus from infecting you. Okay, obviously if it's on your food and it goes in your stomach, that's fine. Your stomach acid is going to destroy it. So all of those are ways that your body has its main defense. The second way is white blood cells. Okay, so white blood cells, for lack of a better term, they eat cells that are infected by the virus. So there's kind of a way that white blood cells know which cells have been infected by the virus, and then they basically destroy that cell that's been infected by the virus. Number 3, inflammation. So cells that are damaged release this chemical, causes swelling, and so this attracts the white blood cells. You see there WBC, that's white blood cell. So it attracts the white blood cells to the area, and then the white blood cells will eat the cells that are infected by the virus. Okay, once you have had a virus, you should have acquired immunity. So it says there after first exposure. Okay, so you can acquire it after your first exposure to the disease. And then it's possible, this is with other viruses. Obviously, COVID is too new, but it's possible that you get passive immunity from your mother during birth, or as it says here, if there's some way we can inject you with antibodies, right? But we don't, it's too new, okay? So treating it right now, we don't really have any great treatments, which is why everybody's at home, okay? So it's basically your immune system. It's just your immune system is what you're going to use to fight this off. And so if you can't fight it off yourself, so people who are at risk, so very, very young, very old, people who are already sick, people who have compromised immune system, other health issues, it's going to be much harder. So what happens is that there's inflammation in your lungs. It makes it really hard for you to breathe, which is why you need a respirator. So you need a respirator to breathe until their immune system can eliminate the virus. So basically you need something to help breathe for you so you can kind of ride it out until your immune system is able to sort of fight off all of the virus in your body, because we don't have, I guess, any drug to kind of fight this virus. Okay, so you have to kind of ride it out. So this is a really good graph. Shout out to Miss Nisho for finding all this info. There's a lot of stuff going on in this graph, so let me try my best to explain. Cases of COVID over the last month or so. So this goes from March 19th to April 30th. So in this graph, there's a lot of info, so I'll try to walk you through it. So basically the red bars are anything that, this was the projections of what would have happened if we kept business as usual. So if we told you, oh, March break is over, we're going back to school, everyone go back to work, everyone just do your normal lives. Based on what we know about how fast the virus spreads, the red shows you the projection of what would have happened if everyone kept doing what they were normally doing. Okay, so you can see that we would have had way more cases. So the next thing you'll notice is all of the graph that's in green. So green is the data that we have so far. So this data goes all the way till April 1st. It's a little bit old, but hopefully they'll update this graph. So basically you can see here that we saw the numbers going up in terms of the green bar. So that's officials made the decision to, the self-isolation, quarantine, all those things keep people at home. So this is the basic idea. So right now, hospitals have this capacity. So this purple line right here in Ontario, it says right here, we have around 410 available ICU beds for COVID patients. So this is respirators, all those things, the people who need like emergency care. So right now we're at 410. In the case of an emergency, we believe we can easily get to the 900 additional beds that we need for COVID patients. So our new maximum for the number of people we can have on respirators and the number of people we can safely be treating in a hospital is right here. Okay, so we were hoping that with the self-isolation, with all of those measures, the predicted metric for the best case scenario is that we would have a situation where, yes, more people would be infected, but that hopefully we wouldn't get this massive spike. Okay, so when they talk about flattening the curve, this is what they're hoping. They're hoping that the curve doesn't get so high or doesn't grow faster than the number of beds that we have in the hospitals, right? So the idea is we know people are going to get infected. We know a certain percentage of the population is going to have to be in a hospital bed or need a respirator. So the idea is if you don't go outside, if we can lower the amount of people who are being infected, then we can make sure that the number of cases are underneath this bar here, this purple line, because that's what was happening in Italy, where they had so many cases that they just ran out of respirators and there's nothing really you can do. So we're hoping in Canada that if we do this and we did it fast enough, that we will always have enough respirators. So this is the kind of graph that explains for Ontario. So what do you have to do, or can it be prevented? So yes, 50% of people who test positive for it have no symptoms. So you might be talking to people and they're saying like, no, I feel fine, everything is good. Because again, your immune system fought it off. Great, that's good, you're lucky. So the things you could do to help prevent you getting it, right, is self-isolation. Obviously, we're all doing that. You kind of have to. It says here, keep 2 meters away from people. So that's the social distancing that they keep talking about. Okay, washing your hands. And I know this sounds ridiculous, but you have to wash your hands longer than you think is normal. This goes for any time, but when you're washing your hands, it should be 20 seconds at least with soap. So you're spending a lot of time at the sink washing your hands with soap, so just making sure you're doing that more than you're used to. Okay, and if you don't have access to soap, that's when you go to the hand sanitizer. So they recommend at least 60% alcohol. All of the hand sanitizer you have will have this alcohol content, 60%, which is enough to, it says here, destroys the coat. What they mean is the virus has this outer coating, okay, and the 60% alcohol is high enough alcohol that it sort of destroys that viral coat. So now the virus has no way of entering your cells because the coat has been opened up, the genetic material is just out there, so it has no way to enter your cells. So in a sense, it can't hurt you anymore, right? Obviously, if you have to sneeze or cough, do it into your elbow. That's pretty normal advice. Okay, so getting back to normal, we'll see. We'll see when that happens. The CDC will tell us when that's going to happen. And again, normal is going to look different in the future, right? You're going to see more soap. You're going to see more hand sanitizer. It's definitely going to be different after something like this. But yeah, we'll just have to wait and see when we get more info on that. Okay, the one I want to show you last. So your basic goal this week is to find an article. Maybe it's the same graph you found last time. Maybe it's this graph, right? But you're going to find some kind of graph that you wrote a results section for last time, and now you're going to write an analysis section. So I'll give you kind of one website I found really helpful. So this is the Washington Post. They did a simulation called Flattening the Curve, where they explain what the curve is, what we mean when we say the curve, where in the media talks about the curve all the time. So you can see here that they do a simulation of what would happen if you self-isolate no one, and you just let people go about their business based on what we know about how easily this virus spreads. This one shows you what would happen if we just sort of let people go about their daily lives as normal. So you can see that we kind of get this huge spike, and you end up with most of your population getting sick at some point. And then you hope everyone recovers, but we do know that a certain percentage of people don't make it. So clearly you don't want this case where you get this massive spike of everyone getting it at the same time. They also run a simulation of what happened in China when they did the quarantine, where they tried to quarantine as many sick people as they could, and then they started slowly letting people out of the quarantine. So again, this explains, you can see this is also better than doing nothing because you get this kind of flattening effect. Okay, so it's better than nothing, but again, not ideal, obviously. So they run through a few simulations of what can happen, and this is when they get really interesting. They talk about social distancing. So they say what you do is you only let 25% of your population move, and you tell everyone else to stay at home. So this is a simulation of what would happen if you just let most of your population, you make most of your population stay at home, but you let, let's say, 25% move around. So you can still see that you're not getting this huge spike where everybody is sick at the same time, because again, you don't want everyone sick at the same time. It has to do with hospital beds. Okay, you only have a certain number of hospital beds. So yes, people are going to get sick, but you want it to be as spread out as possible so you have enough respirators for everybody. And then this is the last simulation where they say, okay, instead of 25%, what if it was half of that? So what if it was like 1/8 or something, or 1 out of every 8 people was allowed to move? Okay, so this is when you think, okay, only people who are doing the supply chain, only people who, absolutely have to go to work to the hospital, only people who have to work at the grocery store. So very few people are allowed to move in this scenario. And you can see what happens when we all sort of do our part and stay at home. And you can see that we don't really get a huge spike. Okay, so every time you run the simulation, you're going to get slightly different numbers. That's way flatter than I've ever seen it. But it kind of runs through it randomly every time. But again, it just shows you that, I know it seems like, oh, I'm just at home, I'm not doing anything, but you kind of have to, because you want very, very few people to be walking around and sort of possibly spreading this virus, okay? So again, you can see this time around the simulation, very, very few people got sick. Most of them stayed healthy. So this is the idea. If you're able to keep it as low as possible, then this is the goal, right? So today what you're going to do is you're going to use the same graph you had last time, and you're going to write an analysis section, or you'll find a new piece of data and you'll try to explain why it's happening. So this is where you get into the science of like talking about the probability of getting sick, or you talk about something about the chances of it spreading, or you're trying to get into more of the science of like what explains your data. Okay, so instead of last week, we just said what is happening in the data. We just described, is it going up? Is it going down? Is it flattening? What's happening? Today, you're going to go into the science of why is it happening? Okay, so results section is what is happening. Just describe it. This week is analysis section. Why is it happening? Okay, so spend a paragraph, have one citation, okay, at least. One citation should be enough. But just, it could be a news article. It doesn't have to be like a primary journal for this one. There should be plenty of news sources that are pretty useful for this. So just any one source, and then use that to help you describe why your data is happening. Okay, and that's it. Okay, bye everyone.